Good morning, students. This is the session 4 from the playlist of NEET Physics Part 2. The chapter is Electric Charges and Field, and today I have taken this question for this session, and this question was asked in the CBSE All India Pre-Medical Test in 2004. So the question here is, a bullet of mass 2 gram is having a charge of 2 microcoulomb. Through what potential difference it must be accelerated starting from rest to acquire a speed of 10 meter per second. So this question is a very easy question, and here we will be applying the concept of work energy theorem. Now, according to the work energy theorem, the change in the kinetic energy is equal to the work done by the net force acting on an object. So this is the basic definition of the work energy theorem, and we will be utilizing this concept in order to solve this question. So here the change in the kinetic energy, first of all we have to find the change in the kinetic energy. So since this bullet is starting from rest, so initial kinetic energy is equal to 0. The initial kinetic energy of this bullet will be equal to 0, and the final kinetic energy, this will be equal to half mv square, where m is the mass of this bullet and v is the, you can say, the final velocity of this bullet. So I am just denoting that final the speed as 10 meter per second, which is, so the change in the kinetic energy will be equal to change in the kinetic energy will be equal to 1 by 2 mvf square, where vf is the speed, that this is the final speed of this bullet. Now we have to, as per the work energy theorem, the change in the kinetic energy is equal to the work done by the net force acting on the object. So in this case, if this bullet having a charge of 2 microcoulomb is accelerated through a certain potential difference, then the work done will be equal to Q into V, where V is the potential difference through which this bullet is accelerated. So now, as per the work energy theorem, this half m, that is the change in the kinetic energy, should be equal to the this work done. So this is equal to Q into V, and we are now supposed to find the potential difference through which it must be accelerated. So V, it will be equal to m vf whole square divided by 2q. So this is the formula which we have been able to derive by using the concept of work energy theorem. So the potential difference will be equal to, now mass is 2 grams, so I will be converting it into kg. So this will be equal to 2 into 10 to the power minus 3. The final velocity is 10 meter per second. So this will be equal to 10 square, and divided by 2 into Q. Now Q is the charge on this bullet, so this is 2 microcoulomb. So I will be converting this into coulomb. So this will equal to 2 into 10 to the power minus 6. So from here this 2 and 2 will get cancelled out, and I will be getting as 1 by 2 into this is equal to this minus 6 will go in the numerator, and it will become 10 to the power 6. 6 minus 3 will become 3, and so this will be equal to 10 to the power 3 into 10 to the power 2, and this is equal to 1 by 2 into 10 to the power 5 volts. Now here we have been given 4 options here. So this is a high potential difference. So we will be now converting this in kilovolts. So this is equal to 1 by 2 will be equal to 0.5 into let us say it is into 100 and into 10 to the power 3 volts. So I have split this 10 to the power 5 in 2 parts, that is 10 to the power 5 is equal to 10 to the power 3 into 100, and now this 0.5 into 100 will be equal to 50 into 10 to the power 3 volts, or we can say that this is equal to 50 kilovolt, because 10 to the power 3 volts is equal to 1 kilovolt. Okay, so this bullet should be accelerated through a potential difference of 50 kilovolt in order to acquire a speed of 10 meter per second. So here the correct option is B. Okay, so in this question the most important thing was that you have to utilize the concept of work energy theorem, and using that concept you can easily solve this problem. So thank you very much for joining this session, and in the next session I will be continuing with the same chapter, that is electric charges and field, and I will be coming up with some different type of a question which has been asked in the previous year NEET and the CBSE examination. So till then, have a nice day. Bye.